Hi, this is Rob. I'm going to show you how to do the exercises that go along with the Math Antics video lesson, Division, the Partial Quotients method. Are you ready? Let's go. And we're given one instruction for all four problems this time. We're told to use the Partial Quotients method to solve these division problems. And we're given the note that each student's answers should match the answer key, but the path they take to get to it may be different. On the answer key and the way I'm going to show you, will be a certain set of steps, but you can get the same answer with a different set of steps, just like we showed in the video. For problem 1, we have 472 divided by 16. And the first thing we need to do is choose what multiples of 16 we want to use as our partial answers. So multiplying by 2 is always a nice easy one, so let's start with that. We'll have 16 times 2. And 16 times 2 is 32. And let's also go ahead and just double that. We'll get 16 times 4. So we'll have 16 times 4. And, since that's double, double 32. Twice 32 is 64. And then also multiplying by 10 might be useful. Let's get that in here. So 16 times 10. And multiplying by 10 is really easy, which is why it's such a great choice. 16 times 10 is 160, and those should be good. Those should be good for now. So let's start getting the answers here using these multiples. So for the first one, what we still have is 472. We still have the whole amount. So we'll use our biggest multiple here. We'll use our multiple of 10. So we'll write 10 right here, and then we'll put 160 underneath what remains, which when we're starting is the whole amount, and then we subtract that. So 472 minus 160 is 312. So once again, that is bigger than 160. So we'll use 10 as our multiple again. Use 10 right here. 160. So we'll subtract 160 from 312, and that is 152. And so 152 is less than 160, so we can't use 10 as our multiple again. So we'll use 64 because that's smaller than 152, so that will work. So we use 4 as our next partial quotient, and so we'll subtract 64 from 152, and 152 minus 64 is 88, and 88 is still bigger than 64, so we can use 4 again as our multiple. Boy, we are getting really close to the bottom here. I hope there's going to be enough room. I might have to carry it off to the side. Let's see. So once again, we're going to subtract 64. So 88 minus 64 is 24. Oh, look how tight that is. All right. So we'll just continue over here. So, but 24 is smaller than 64, and in fact, it's smaller than 32, which is just the multiple of 2. We have 24, and we'll subtract 16. We'll just use a multiple of 1. So we have 1 off to the side there. So 24 minus 16, and that gives us 8. So that is as many steps as we can take. That's as small as we're going to get our remainder. So let's add all these up. So we have 10 plus 10, which is 20. So we have 20 plus, and then 4 plus 4 plus 1 is 9. So that equals 29. So our final answer is 29, but don't forget this right here, with a remainder of 8. So 472 divided by 16 is 29 with a remainder of 8. And remember, you might have taken different steps to get this, but as long as this is your final answer, then you got it right. For problem 2, we have 5,675 divided by 21. So once again, we're going to need to pick our multiples, and we'll probably want some pretty big multiples because 5,675 is quite a bit bigger than 21. So let's see. We'll go ahead and we'll still start out with multiple of 2. So times 2. 21 times 2 is 42. And then let's go ahead and multiply that by 10. So we'll do 21 times 20. So let's do that here. 21 times 20. So that's going to be this times 10. That's 420. And then let's see, let's multiply the whole 21. Let's do it by 100. Let's do 21 times 100. That's not lined up very good. Sorry about that. But it's a little hard to do on the screen like this. Sorry. And then let's see. Oh, that will be very useful, but it's also very big. We might want something a little smaller than that. So let's try half of that size. So instead of multiplying by 100, we'll multiply by 50. So 20. I think I can fit that right here. Even it'll be a little crowded, but so 21 times 50, and then we know that it will be half of this. So it will be 1,050. All right. So this looks like a good set of multiples, and in fact, it might be more than we need. But this is a big number, so let's get going. And I see that the biggest multiple that we've chosen to work with, 2,100, is less than what we have here. So we'll go ahead and start with that. Start with not a whole lot of room to put that there. I hope that doesn't get in the way. Okay, so we'll be using the multiple of 100, which is 2,100. So we'll subtract 2,100 from this, and 5,675 minus this. Well, let's just do 5, 7, 6 minus 1 is 5, 5 minus 2 is 3. So 3,575 is what we have now, and that is still bigger than 2,100. So let's use the multiple of 100 again. So once again, we'll subtract 2,100. So we have 5, 7, 5 minus 1 is 4, 3 minus 2 is 1. So now we have 1,475. So that's too small to use this as our partial answer, our partial quotient. But it's not too big, not too small. It's not too small to use 50 as our multiple. Let's use 50 because that comes out to just 1,050, and that's small enough to use here. All right, so we'll subtract 1,050 there. I'll put the minus sign there. So we have 5, 2. So 425 is our current remainder, and that's still quite a bit larger than 21. So let's keep going, and let's see for this step. So 425, well, this would be perfect for it, the multiple of 20. Let's use 20 here. So 425 minus 420 is 5. And so we're done, because 5 is too small to be divided up anymore. So 5 is our remainder. So we'll add these up. We have 100 plus 100 is 200, plus 50 plus 20 is 70, so 270. With the remainder of 5 is what you get when you have 5,675 divided by 21. For problem 3, we have 8,476 divided by 325. So once again, these are big numbers, which is a perfect division problem for the partial quotients method. Let's see, and so once again, we're going to start by picking our multiples, and we'll get a multiple of 2 again. So we have 325 times 2. So that, we'll just double that, so that will be 650. And then let's see, let's go ahead and double that again. So we'll have 325 times 4, and 650 doubled is 1,300. And then let's see, let's go ahead and do a multiple of 10. So we have 325 times 10, and that will be 3,250. That should be pretty useful. All right, so let's get started. We have, we're working with 8,476, so we can use our biggest multiple here, because that's still less than that. So we will subtract 3,250. And let me write down what multiple that is. That's 10. So let's subtract that. So we have 6, 7, minus 5 is 2. 4 minus 2 is 2. 8 minus 3 is 5. So we have 5,226 still. And so we can take another big chunk of it with our multiple of 10. We'll do that again. Minus 3,250. So we have 6, and then borrow 1. So 12 minus 5 is 7. So we borrowed 1, so that's 1 up here. Borrow 1 from here. 11 minus 2 is 9. This is 4 now because we borrowed from it. So 4 minus 3 is 1. So 1,976 is what we're working with now. And now that's too small to use 10 as a multiple, but we can use 4 as a multiple. So let's put a partial answer of 4 here. And that's going to be 1,300. So 1,300 subtracted from this. That gives us, and then 9 minus 3 is 6, and 1 minus 1 is 0. So 676. And let's see what multiple we want to use. Well, 650 would be great because it's almost that, but not more. So we get to use our multiple of 2 here. So we subtract 650. So 676 minus 650. So we are good. Let's add this up. And we have 10 plus 10 is 20, plus 4 plus 2 is 26, with a remainder of 26. That looks unusual, but that's just the sort of thing that can happen. 26 with a remainder of 26 is what you get when you divide 8,476 by 325. For problem 4, we have 1,349 divided by 78. So we'll get our multiples of 78 here. Let's see, we'll start with 78 times 2, as we often do, because that's a pretty straightforward thing to do, is to double something. Although 78's like not as obvious for doubling as others. You do have to do it digit at a time, unless, well, some of you won't, but so 2 times 8 is 16, and then 2 times 7 is 14 plus that 1, so 156. And then let's also use a multiple of 10, because that'll get us to a bit more useful size, and it's very easy to multiply. So 78 times 10 is 780, and let's see if those two will be enough. So 780 is a very good first step here. We'll use a multiple of 10, and then we'll subtract 780 from 1,349. That gives us 9, borrow 1 there, so 14, so 6. So this went down to 2 because we borrowed from it. So 12 minus 7 is 5. So 569 is what we're dealing with now. And so that is, that's too small to use our multiple of 10, so we're done with that. But we can use our multiple of 2 here. And we could, if we wanted, we could make, go up, make a multiple of 4 and something, but we'll go ahead and just use a multiple of 2 a few times here. So 156 minus that. So 9 minus 6 is 3, 6 minus 5 is 1. So we have 413. So let's go ahead and just use the multiple of 2 again, because it's not too large for this. We could cut out a couple of these subtraction steps if we made a larger multiple, but we can also just do multiple subtraction steps. Let's see. So we'll borrow 1 here. So 13 minus 6. So this is down to 0. So we'll borrow 1, make it 10. So remember we borrowed from this, so that's a 3. So 257 is our remainder right now. So let's keep whittling away at it. We'll use the multiple of 2 again, minus 156. So 7 minus 6 is 1, 5 minus 5, 2 minus 1. So we're at 101, and now our multiple of 2 is too big. So 101 minus 78, and see, so we carry, not carry, we borrow 1 there, so 11, so 3, so that went down to 9. 9 minus 7 is 23. Well, let's add up all our partial answers here, our partial quotients. So we have 10 plus 2 plus 2 plus 2, so 16 plus 1 is 17. So we have 17 with a remainder of 23. And that is what you get if you have 1,349 divided by 78.